Hey there, Chem students, Mr. MB. Hope you're having a good day so far. We're going to get into it here in a moment. So make sure you're ready to go. You'll see the reminder in a second to get your notes out, but you can grab them out right now while you're listening to me get started. Today, we're going to be talking about unit conversion, specifically SI units of measurement. There we go. I can get it. All right. So stop, pause this video if you need to. Take out your guided notes, a writing utensil, and a calculator, and we'll get into it. So our goal for today is that you will be able to use SI units appropriately for measurement and conversion. So it's not just going to be me giving you numbers and you need to convert them. You get to do the measuring. The great thing about science is you get a lot of hands-on stuff. So we're going to be doing some measuring, some converting, and I think it should be a really good time. So remind ourselves, SI units of measurement, that's that international system of units. So it's not what we use in the United States, but it's what the rest of the world uses. And specifically what we're going to be using in this class are these ones in yellow, okay? So anything in these yellow boxes, if you don't have a yellow box on your paper, make sure you put some like highlighter or square or something around yours. But we have length, mass, and time. Thermodynamic temperature is really just temperature. We have the amount of substance. Don't worry about that right now, but we'll get to it later in the course. But then over here, you have volume, and you also have density, okay? So these are the things that we're going to be measuring, and I know that we talked about how there's that number line, the powers of 10, and that's important to know, but really for a high school chemistry science class, you're just going to be using kilo, deci, sometimes centi, and then milli. Actually realizing deci you probably wouldn't use all the time. I think I was trying to highlight there like what would be the base unit, but really just kilo, centi, and milli. You won't use the other ones too often. If you take a class in college, you might hear like nano. I've heard pico before, but a lot of those other ones we just don't use. I can't speak for physics, but that's at least chemistry. So if that's helpful, or maybe relieve some fear from you of all these things you need to memorize. Hopefully it does. But let's go through here. What are our base units of measurement? So when we're talking about length, we're going to measure that in meters. And an abbreviation, kind of shortened version, is that M. Okay. Mass is going to be grams. We'll use a G. Time, usually in seconds. It's an S. Temperature can be degrees Celsius. So we won't use Fahrenheit. Looks like this. Sometimes you might see something with a K. That K stands for Kelvin. That is something that you will see. Just want to make sure you know about that. Volume is technically a derived unit. So if we take, if you think about taking the volume of a square, for example, you take the length times the width times the height, that gives you the volume. So you're actually getting that from this base unit of length. But for volume, we oftentimes use milliliters. I guess I could write that out for you. Milliliters. Or if it's a bigger quantity of something, you'll see it as liters. So bigger quantity there, okay? And fun fact, a milliliter is based off of 1 centimeter cubed. So a little box here, 1 centimeter by 1 centimeter by 1 centimeter, all that area together, or volume rather, is a centimeter cubed. So that's a milliliter. And then density is when you take the mass of something divided by its volume. That gives us density, and we'll do that in usually grams per milliliter, sometimes kilograms per milliliter. Okay, so you got those. And I know we looked at that number line. I actually have it here for you to look at to remind you. And there is this base unit that we start with. And then as you go to the left, you're getting bigger. So it's like 10 to the third, so 10 with 3 zeros, or 1 with 3 zeros. If you go to the right, they're getting smaller. So a centimeter, a millimeter is smaller than a meter. That's going to be with a decimal point. So we have those things. And really, like I said, we don't use all those super often, but it's good to know those. So what we're going to use the most often with length is, we start with 1 meter. We'll sometimes use kilometers, and 1 meter is 0.001 of a kilometer, because there's going to be 1,000 meters in a kilometer. There'll be 100 centimeters in a meter, and 1,000 millimeters in 1 meter. So it's kind of like all those things connected. For mass, similarly, there'll be 1,000 milligrams in 1 gram, or 0.001 grams per kilogram. Same thing over here. I don't know why I wrote this twice over here. You don't really need this. So 1 liter is equal to 1,000 milliliters, okay? So I wanted to make sure you saw that. This last stuff here, we're going to kind of move through it quick. Don't need that with us anymore. Just some lab technique stuff, because you're going to be doing a lab to practice this. When it comes to taking the mass of something, just checking our time, let me move quickly here. When it comes to measuring something with our scale, there's this cool button right here. It is the 0 button. So as soon as you put your object on here, say you put, I don't know, a square on here, you need to push, or you would want to make sure it says 0 before you start. So say somebody else had used it and there's a different number. You push 0, it should read like it does here, 0, 0. You put on your square, and then you're going to get the mass of it, okay? And you'll write it oftentimes in grams, so maybe it's 0.2 grams. Always include that unit there. You always want to have that, okay? We're going to do a visual walkthrough of some lab technique stuff, but here's a reminder for you as well. When you do volume, we use this thing here called a graduated cylinder. And with the graduated cylinder, we can measure the volume pretty precisely. Water has this sort of property where it has a surface tension, and it's going to make this sort of like curve here. Well, it's kind of a shaky curve, but you can kind of see what I'm getting at. I might actually just move it out of your way so that you can fully see it. But there's sort of that curve there, and it's called the meniscus. You're going to measure at the bottom of that meniscus. So I know that here, if you look at it, it might say, oh, look at this, looks like 68, because it's right there. But you actually measure at the bottom. So 67 milliliters would be the volume of liquid. Let's say it's water that's in this graduated cylinder, okay? Keep it moving. When you look here, it's just a ruler. You've seen these before, but we're going to use the metric side, so not this side, not the inches. We're not using that, we're using the metric side. And each of the big numbers is a centimeter. So this is 1 centimeter, 2 centimeters, 3 centimeters, and each of the little ones are millimeters. So if we measure something and it goes from here to here, that's 1, 2, 3, 4, 5, 6 millimeters, or 0.6 centimeters, or 0.006 meters, okay? So you can do that conversion quick by just moving the decimal point. Last one, let's bring us home. Lab technique with the thermometer. There is this hold button on here. And the hold button, if your number's flashing, that means it's holding the last measurement, and you're not going to get an accurate read. So if it's flashing, push that again so that it gives you the number or the temperature that you're actually getting in that moment. The on-off switch is right here. And then the last thing with this is if it's reading in Fahrenheit, so if right here it says F, you need it to be in Celsius. So on the back, there's a little button and you can push. So like F/C, you'll just push that. It'll switch it to Celsius. So that's all I got for you for right now. I hope that was helpful to go over how we're going to do some measurements in this class, and then also talk about the specific ways that we will measure things.